Hello everyone! Well, look at this cone. Your teacher wants the total surface area. You see 6 feet, you see 3 feet, and your first instinct is probably to just grab the numbers, throw them into a formula and move on. But wait! This is exactly where thousands of students lose easy points on geometry tests. Is that straight vertical segment, AB, the height, the side we actually need to wrap up? Nope, that's the trap. We are going to unmask this geometry riddle right now. By the end of this video, you won't just solve this problem. You'll have a foolproof mental checklist, so these shapes never confuse you again. Let's back up for a second. Well, surface area. What's the big deal? Think about wrapping a perfect birthday gift, like a traffic cone or a cool party hat with zero overlap. How much paper do you actually need to cover the whole solid object? For a cone, there are two distinct parts we need to wrap. First, you have the bottom, the flat circular base. We know how to do that from middle school. That area is pi r squared. Easy, right? The second piece is the curved party hat part that goes all the way to the top. That's called the lateral area. The formula for measuring its area is pi r s. Now, look very closely at that s. That s stands for slant height. That is the length of the escalator ramp that runs up the outside of the cone segment AC. It is not the vertical elevator shaft that runs straight through the middle segment AB. To calculate the surface area, the wrapping paper, we must know the radius r and the slant height s. The formula does not care about the interior vertical height h. So, our total surface area formula is base area plus lateral area, or pi r squared plus pi r s, where r is our radius here. Now, look back at our problem image. What do we actually have? We have the radius of the base, r, segment BC, which is 3 feet. Perfect. We have r here and here. But what is that 6 feet? It's segment AB, which runs vertically straight from the point to top to the center of the bottom circle. That is the height h, not the slant height s. So, step 0 of this problem, we cannot move forward until we find s. But look closely again. See that beautiful right angle symbol at point B. The vertical height segment AB is perpendicular to the base radius segment BC. Inside every right cone is a right triangle waiting to save you. The vertical height and the radius are the two legs, and the slant height s is the hypotenuse. We are missing the hypotenuse. Well, now it's time to call our old high school geometry best friend, Pythagorean Theorem. Okay, let's write it down and solve this together. A squared plus b squared is c squared. In our cone language, that's r squared plus h squared equals s squared. Let's plug in the numbers we know. 3 squared plus 6 squared is s squared. Pause the video right here and figure out those squares. Ready? 3 squared is 9, 6 squared is 36, is s squared. Adding those up, we get 45 equals s squared. But we don't want s squared, we want just s. To undo the square, we take the square root. So, s is the square root of 45. Depending on the teacher, you have two options now. Let's start with simplifying the radical for maximum exact math points. 45 is 9 times 5. So s is square root of 9 times 5. Since the square root of 9 is 3, we get s equals 3 the square root of 5 feet. If your teacher prefers decimals, plug 3 square root of 5 or square root of 45 into your calculator, and then you'll get that s is roughly 6.71 feet. Well, you see, the hypotenuse must be the longest side, and 6.71 is bigger than 6. This makes geometric sense. We got it. Okay, great. Now we have everything we need. R is 3 and S is 3 square root of 5. Let's do the actual surface area steps now. Follow along on your paper. Step 1. Find the area of the base. Formula: pi r squared, and in our case is pi 3 squared, equals 9 pi square feet. Step 2. Find the lateral area, the curved wrapper. Formula: pi rs is pi 3 times 3 square root of 5. Multiplying the non-root numbers gives us 9 pi square root of 5 square feet. Now step 3. Stick them together for a grand total. Total surface area is base area plus lateral area, which is 9 pi plus 9 pi square root of 5 square feet. Here's the major common mistake alert. You cannot simplify that expression into 18 pi square root of 5. These are not like terms. One is just 9 pi, and the other is 9 pi times foot 5. They must stay separate. We can factor out 9 pi to write the final, slickest exact answer. If you need a rounded decimal answer for your test, you can plug all that into your calculator, and you'll get approximately 91.5 square feet. And that is our answer. Okay, let's recap. When you see surface area of a cone, first, don't use the interior vertical height h. That's for volume problems. Find the slant height s, first by using the hiding right triangle and the Pythagorean Theorem. Then use the full surface area formula, base area plus lateral area. Here's a quick pro tip for your next test. Always read carefully. Does the question ask for lateral area only, like finding how much material is needed to make a party hat, or total surface area, wrapping the entire solid cone? Lateral area is just the wrapper, PRS. Total area includes the base. Don't waste time calculating the base if they don't ask for it. And again, the most common mistake students make: plug in the vertical height h directly in for s in the surface area formula. You're now way smarter than that trap. You just mastered finding missing cone dimensions. Go crush that test homework assignment. You got this. Well, thank you for watching, and I will see you in the next video.